Assalamualaikum and hi. So now we are going to look at pure inductor in an AC circuit for chapter 6. So what we have here is we have our circuit connected to an AC power supply across an inductor here. Okay, so pure inductor means that no resistance and capacitance effects in an AC circuit. That means we are not having any resistance presence or any capacitance present in the circuit. We only have inductor. Okay, so the current flows in the circuit is given as I is equals to I naught sine omega t. So whatever current that is flowing inside here is alternating. So we have I is equals to I naught sine omega t, which will produce us a sine graph here. So this is the graph of the I is equals to I naught sine omega t. This is the graph for I. Okay, let me use the red color one to show you for the graph of I. So this is our I. The maximum current that we reach here is I naught. Okay, one complete cycle period T, and then we have two complete cycle here, and we start at when T is equals to 0, our I is equals to 0. We obey this sign shape here. And then next, when the current flow in the inductor, there is back EMF caused by the self-inducting is produced and given by. So when we have current flowing here, we are going to induce EMF, which we call as back EMF, which is due to the self-induction process that we have studied in chapter 5. So the EMF here, back EMF here, is equals to negative L di over dt. Okay, so our I here is I naught sine omega 2 as sine omega t. So we are going to substitute inside here. So we'll have negative L d I naught sine omega t over dt, and we are going to differentiate this expression with respect to the t now. So as we differentiate here, we will have d I sine omega t with respect to t. So what are we going to do is we are going to only differentiate the term I here. Okay, and then the term I here is inside the sine omega t. So what are we going to do is do not disturb anything in front of sine omega t, such as your I. Just rewrite your I. And then for your sine omega t or sine omega t, bring your omega in front. Okay, bawa omega ke depan. And then kita jadikan sine sekarang jadi cos omega t. Differentiate sine dapat cos. So this is what you got. They're going to substitute I naught omega cos omega t into the equation, and you have your EMF, back EMF is equal to negative L I naught omega cos omega t. At each instant, the supply voltage V must be equal to the back EMF. So whatever voltage that this power supply is going to give is going to equal to the back EMF. Okay, at every single time. So we can conclude here, the supply from EMF is going to equal, the supply from the power supply is going to equals to back EMF voltage across the inductor, but the back EMF also oppose the supply voltage. Hence, the magnitude of V and B is given as, okay, we are talking about magnitude. V is equals to EMF B is equals to Li omega cos omega t here. Okay, so to change this cos omega t into sine omega, to change that into sine angle, so what happen is it becomes as omega t plus pi over 2. Okay, sebab kita nak tukar shape cos ni pergi ke shape sine. So dia akan jadi omega t plus pi over 2. So V naught here is known as Li naught omega. So this whole term here now becomes your V naught. So what we have here is the supply voltage is equals to V naught sine omega t plus minus pi over 2. Ini kita dapat sebab kita ada equation yang cos dekat sini. You have a cos equation here. Okay, and then this cos kita tukar pergi in terms of sine sebab kita nak guna unit yang trigonometry yang sama dengan current tadi tu. The only reason why is because we are going to find the phase difference. As if you still remember, I mentioned that when we study about pure resistance dan pure capacitor, untuk cari phase difference, okay, nak cari perbezaan phase, iaitu phase adalah sin phi tu. So untuk I kita ada sin omega t, untuk V kita ada cos omega t sebenarnya. Okay, this was your sin equation, this one. This is your phi. Ni adalah kamu punya V punya equation. Okay, V sama dengan this much. So this is your phi omega t ni. Tapi however, they do not have the same shape. Okay, so to find the difference in them, kita kena tolak dia bila mereka berada pada bentuk yang sama sahaja. Maksudnya sin kena tolak dengan sin, cos kena tolak dengan cos. You cannot sin minus cos. Dia sama macam contoh x axis tolak y axis, tak boleh. X kena tolak x, y kena tolak y. So for that you have to change it to sin. So bila dah tukar pergi sin, dia jadi sin omega t plus pi over 2. So kita ambil phi V tolak dengan phi I, iaitu angle of V, phase angle of V tolak dengan phase angle of I. Phase angle of V adalah ini, this whole thing, omega t plus pi over 2. Okay, lepas tu tolak dengan omega t yang ini pula. So kita dapat pi over 2 here. So your phase difference here is by pi over 2. Sebab V yang tolak I, dan kita dapat positif, so V akan lead I by pi over 2. Okay, V yang tolak I, kan, V tolak I, and you get a positive answer, maksudnya V is leading I by pi over 2. Okay, so berdasarkan sini juga, berdasarkan equation yang ini, so you can see this equation here, V is equal to V0 sin omega t plus pi over 2. Kita punya graf dekat sini adalah graf untuk, okay, ini graf untuk V yang memenuhi syarat V is equal to V0 sin omega t plus pi over 2, ataupun sebenarnya dia adalah cos omega t. V0 cos omega t, bentuk cos, betul tak? Bentuk cos. Sebenarnya dia adalah sine graph yang has been shifted by pi over 2. Dia adalah sine graph juga. Cuma kita dah shift this axis ke kanan by pi over 2. So positive pi over 2 dekat sini. Okay, so you don't have to worry much about the sketching of the shape, sebab ini memang tetap. Kalau I, dia memang sin omega t. Kalau V, dia adalah sin omega t plus pi over 2. So dia akan start daripada atas sini. Okay, so from here we can conclude that the I, when t is equal to 0, I berada dekat 0. However, the V pula, bila t is equal to 0, your V is at maximum, sudah berada dekat sini. So this phasor shows you that, this phasor diagram shows you that V is leading I by pi over 2. So graph V mendahului I. Okay, your V is leading I by pi over 2. Okay, so in pure conductor, V leads I by pi over 2. Ataupun boleh juga cakap I yang lambat by pi over 2. Sebab V dah dekat sini, I masih dekat sini. So kita boleh cakap I lambat. Tapi stick to one sahajalah, so that you do not get confused. So the inductive reactance in pure inductor is given as pula, okay, di sama konsep macam kita guna kaedah Ohm's law, V is equal to IR, kan. R adalah bila it is resistance. Dekat sini kita guna reactant untuk oppose. Yang penting adalah it is still to oppose the current. So kita punya equation akan jadi V is equal to I, whatever reactant yang kita guna dekat sini. Reactant kita adalah inductive reactant, so dia jadi XL. So XL ini akan sama dengan V, sebab we are talking about RMS here, akan jadi RMS. Okay, tapi kalau kita talking about V0, dia akan jadi peak, dia akan jadi V0 dengan I0 dekat sini. However, V0 ini tadi kita cakap sama dengan L I0 omega. So you're going to substitute that inside here. L I0 omega bahagi dengan I0, kita dapat L omega. So your XL adalah L omega. Omega ni apa? 2 pi F. Okay, so your inductive reactance is equals to angular frequency darab dengan inductor, ataupun 2 pi F darab dengan L itu. Okay, for instantaneous power pula, we are going to start with P is equals to IV. Alright, So I square darab dengan R, and then we get V square over R. So kita ada 3 equation lah, kita derive lah daripada equation of power itu. Okay, so let's say we want to use this one, I V. I adalah, berdasarkan yang dekat atas ni, I was I sin omega T. So you take that, you write here I sin omega T. V pula tadi adalah V0 cos omega T. Yang ini. Sebelum kita tukar dia pergi sin. Dia adalah yang cos ini. Okay, ini kan V0 tadi. This one is your V0. So dia adalah sebenarnya V0 cos omega T. Okay, so kita buat darab I0 V0 sin omega T darab cos omega T. You should get this is identity, half sin 2 omega T. And then I0 V0 ni sama dengan P0 sebenarnya. P0 half sin 2 omega T. So ini adalah bentuk graf untuk equation ini, half sin 2 omega T ini. Okay. So when you sketch your graph, as you can see, you have half the cycle on the positive side and another half the cycle in the negative side. Okay, maksudnya half cycle ni, power kita adalah positive, another half cycle power kita adalah negative. Okay, which indirectly gives us an average of 0 dekat sini. So P average kita akan 0 sebab kita ada power yang positive untuk half cycle, power yang negative untuk another half. So dia akan cancel dekat sini. So the inductive reactant XL and frequencies dependence dekat sini, relationship between them adalah, kita akan guna according to this equation here. Di mana kita tengok XL is equals to 2 pi F darab dengan L. So XL here is directly proportional to the frequency. So when your frequency here increases, kita guna simbol impedance dekat sini sebab dalam case pure inductance, total opposition kita berlaku melalui inductive reactance. Okay, the opposition for pure inductor adalah through inductive reactant. So Z kita akan sama dengan XL. So kita get directly proportional dekat sini, straight line graph. Alright, that's it for pure inductor.